Everyone, 1 second. I'll start the class in a minute. So before I start with today's class contents, I'll give you guys a bonus question which you can keep trying. In case you find today's class either repetitive or easy or ununderstandable. I mean, in that case, like you should try to revise your concepts. But try this question. I'll explain it in a minute. Bonus question is not based on geometry progression. It's more of AP based, but right. You can take a screenshot of this. A doctor can treat maximum 10 patients every day, and each patient can have any one of 10 ailments. So, a patient 1P1, if he comes to the hospital, he can have any of the diseases from numbered from 1 to 10. Okay, and the doctor can treat for only one ailment per day. So it's like he gives a medicine, and if the patient gets all right, then he leaves the hospital. If he doesn't get all right, then he'll remain in the hospital for the next day. So doctor is also smart. Okay, he won't repeatedly give the same medicine to the patient again. So a patient uh, can get treated okay, until they are treated maximum of 10 days only. Okay, exhaustively treating for all ailments will cure the patient in 10 days. Also, treatment for can treat them, and any other medicine does not affect the health of patient. So each day they'll have to be treated for another medicine, and eventually that patient discharged from the hospital. Once the patient cured, a new patient all right. So answer is not one, answer will be different. If you think answer is directly 1001, that's not correct. Attempt this question once. Okay, you can take a screenshot of this because I'll not keep coming back to this question. I'll start with more basic stuff related to geometric progression. So in a geometric progression, you have terms like A1, 2, A3 dot N. First term is usually called A. Second term, Manas, not correct. Try again. Uh, Everyone, just keep reading this question again and again. If you find the GP content of the class very easy. Okay. Answer is larger than 1001. Okay. A1, A2, A3, all the way up to AN. The terms are AAR, AR square, and so on up till AR to the power N minus 1. Because it starts with R to the power 0, it goes up till R to the power N minus 1. Total N terms are there in this. This is called the general term. This is first term. Okay. And the salient feature about this is AN upon AN minus 1 is equal to R. This is a constant, non-zero. Because if it is 0, then an will be equal to 0 and next few terms will be 0, and 0 upon 0 is not defined. So preferable, but it's a constant which is a real number. Okay, on this, try the first question. We have reached about question number 19 till the previous class. Try question number 20. Represent 0.123 bar as a fraction. in lowest terms. So 0.123 bar means 0.123, 123, 123, and so on. So we'll keep repeating till infinity. One more thing that I'll mention is Sn is equal to sum of first n terms of GP. Is equal to a r to the power n minus 1 of. So you can keep this in mind while solving question 20. You have to find answer in lowest terms. So Pushkal not correct, Adya correct answer. Pushkal, your first answer is slightly off. Alok correct, Harshit correct, Abhyuday correct, Alok correct. Sharmik answer is not completely correct. It will be less than that, slightly less than that. Chirag correct, Manas correct. Sharmik Shubh correct. Okay, everyone is correct. No one is incorrect so far. I'll give one more minute. Rishit, answer is correct. Pushkal. So over here, the see that whatever number you see, how many ever repeating digits you see, you write that as it is 1, 2, 3, and how many ever times it is repeating, put that many nines below it. This is the fast method to solve this question. If there is some other non-repeating stuff in front of it, you take that and subtract that out of this number, and that will give you your answer. But to do it properly using geometric progression, you can define your first term as a is equal to 1, 2, 3 upon 1000, and r as equal to 1 upon 1000. With this defined, you can see that all the terms, this 1, 2, 3, 1, 2, 3, 1, 2, 3, when taken together, they form a GP, and this number is actually the sum of a GP. And if you use the formula for sum of a GP, you can see, I'll derive the sum of GP formula also after some time. You'll find that answer is Sn is equal to 0.123 bar, which is equal to 123 upon 1000 times. Uh, Here I'll do 1 minus r to the power n, 1 minus 1 upon 1000 to the power n, where n is like going to infinity. So this quantity will go to 0 upon 1 minus 1 upon 1000. So if you simplify this, you'll find that it's 123 upon 999. Divide by 3 numerator, denominator, you get 41 upon 333. Okay, this will be the answer. So let's try question 21. Suppose n is a positive integer in a single digit. uh, okay, is a positive integer, comma, d is a single digit number. So it is between 0 and 9. Find n if n upon 810 is equal to 0.d25 d25 d25 and so on. So this is our infinitely repeating decimal expansion. That is equal to n upon 810. You have to find the value of n if d is a single digit form. The thing about this question is d is not any random value. It has to be one specific value. You don't need to find d. You have to directly find n.
Sir, is we do you need to get it in? Oh, okay, I'm getting an answer. Sir, I'm getting this.
Correct answer. Zaid correct. Pranjal correct.
So, do you use trial and error for this?
You have to use some concepts, some number theory in this. Of course, there are lots of values of d possible, but not all of them will lead to denominator 810
Sir,
in it. Only one particular value
sir, is my
of
answer
d
correct?
equal to 1, d equal to 2, and so on. You have to find the value of d that will satisfy over there also. Put that value of d. Answer is independent of d. You will get one integer as answer. N is an integer, okay? Look, you are on the right track. All you need to do is show that show what value of d will satisfy that equation and make it an integer. You need to figure that out. Manas, you also have to do similarly. Sharmik, correct answer.
So, sir, so now we have to do trial and error.
You have to somehow figure out if it takes trial and error, try with trial and error only, or do something else to figure out what value of d should be there, such that it makes sense to have a. Harshit, not correct. See, Harshit, whatever you might have found might be correct, but here d is a single digit quantity. I'll halfway solve this question and then I'll leave you guys to figure it the rest out. So here, this is an infinitely repeating decimal expansion, d to 5. So I will always consider that d to 5 upon 999 is equal to n upon 810. Okay. Now, why exactly is over here 810? Why not any other number? The reason is that there is something special about this number n. It cannot be any particular integer. It has to be divisible by 30. How did I find that? Because the denominator over here, I can cancel off 20. 9 is actually 1 times. So you have 27.9 and that can cancel from 80. What you will get is that here you will be left with 37 and 810 you will be
Sir,
left
I
with
said my
30.
answer to you.
Manas correct, Shivam correct. So from this you get 30 times d to 5, which is equal to 37n. Now what I'm going to mention is that since this is an integer and 30 is a factor of 37n, this means n. So you can write n is equal to 30a, where a is another integer. Then your job will be done. So this implies you have d5 or 100d plus 25 is equal to 37a. Now, this is a Diophantine equation with restriction that d cannot be more than 9 or less than 0. So figure out for what value of d do you get values of a. And all the GP aspect of this question is done. All you have to do now is solve this equation. Abhyuday correct, Adya correct.
So how did you get D25 by 999?
D25. Oh, that was from the previous question. Like suppose you have this fraction 1, 2, 3. You want to replace terms, no? So you end up getting 1, 9 and 9, correct? Same way I've written. The repeating that
So your voice is breaking. I couldn't hear you.
repeat.
Yes, sir.
See, whatever I did in question 20, I applied it again for question 21.
Yeah, so
Is my
could you,
voice clear?
yeah. But could you just explain like the logic behind making it 999?
It's simple. You can take this number. Let's take the previous example 1, 2, 3, 1, 2, 3, 1, 2, 3, and so on. Let's call n is equal to 0 point this. Now, when n will be equal to 123.123, 123, 123, and so on. Correct?
Yes, sir.
Correct. I multiply this by 1000. When I subtract the second equation out of the first equation, I'll get 999 is equal to an integer 123 because all of this will get cancelled
Okay. Yeah,
when I
got it.
subtract. So then you have n is equal to 123. That is the logic. And that is the logic to do summation of a GP. Okay. Now here, what you can continue with is that what value of d should you put such that this entire number becomes divisible by 37a? The answer for this, I'll give you straightforward without any spending more time calculating. D will be equal to 9 and A is equal to 25 in that situation. And you get N is equal to 25 times 30 is equal to 750. You can check for yourself. Okay, 925 is indeed 37 times 25. The way to do this, I would suggest is write 37, then 74, then 111, and then keep going on like this. At some point, you will hit the proper value. Either do this or you can preemptively divide 100 by 37 and whatever remainder, and then just keep moving, changing values of d such that 26d plus 2 becomes divisible by 37. That might take long. Eventually at 9, in the end you will get that 9 has to d has to be 9 and a is 25, and you get your answer. Try the next question. 22. Let p comma q be real numbers such that mod p comma mod q less than 1. So I'll write them both individually, less than 1, comma mod q less than 1. If p plus pq plus pq square plus p cube dot 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 all the way up to infinity is equal to 2, and q plus qp plus qp square plus qp cube dot 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 all the way up to infinity is equal to 3. Find and pq. So Adya is asking, is there a formula for sum of a GP? There is. If you are new to this, see, I know some of the students in over here now are in 7th and 8th and 9th. You might not have seen what geometric progression, arithmetic progressions are. You might have seen, but not have done enough practice. Uh, but that's why I'm starting at the right at the end of where GP AP discussion ends in NCERT. For an infinite GP, where P and Q common ratio for each of these is equal to A upon 1 minus R. Given is less than 1. Okay, Shivam correct answer. Abhyuday not correct. Aryan not correct. Pranshu not correct. Chirag not correct. Pranshu correct.
Sir, I don't.
Pushkal not correct. Vaibhav Sharmik correct. Shamik correct. This is much simpler than previous question. Okay, I'll start solving this shit. See, you'll get very basic two equations. Abhyuday, not Abhyuday, if you solve that, you'll get the correct answer. Just simplify it. Harshit, correct. See, usually questions, if they are as a fraction,
Correct.
are they correct? Are they correct? So usually if you get answer as a fraction, try to first reduce it. Uh, so over here, first equation, you have the first term as P and common ratio as Q. There is Q square, Q cube. So this equation when written together, they become uh, P plus 2Q equal to 2 and Q plus 3P equal to 3. And after that, it's really easy to just solve them. Better way to write this, in my opinion, is that keep this 1 over here. Put 2 at 3. Now, and you whatever, I mean, somehow you solve it, you get P equal to 4 upon 5 and Q equal to 3 upon 5. These two are linear equations. I'll leave it in its original state. P equal to 4 upon 5, Q equal to 3 upon 5. And then you get 100 PQ is equal to 25 times 4 times 4 times 3, which is equal to 48. So Pushkar and Alok also correct. See, there was nothing very complicated in this question. You just have to understand sum of GPA, apply it. Try this next question. In an increasing sequence of 4 positive integers, I'll just copy this and paste it. So you have 4 terms. First 3 form an AP, last 3 form a GP, and the difference between the first and the fourth term is 30.
So can you please say what is GP?
GP is geometric progression, where terms are of form AR square and so on. So the geometric aspect of this comes from the ratio, common ratio between two terms is same.
So this R is an integer or?
R is a real number. R is number.
Okay.
So for example, you can have 4, 6, 9. This is a very interesting situation. This is also a GP because the common ratio is 3 upon 2. Even though they don't look like, it doesn't look like a GP instantaneously, it is a GP. Okay, those who are not able to proceed anyhow in this question, can you write all the terms as a plus d, a plus 2d, and minus a plus d. Can this be done? Because from this you have written the first three terms as a AP. Then the product of the adjacent terms must equal the middle term ka square. So keeping that in mind, I have written the fourth term in terms of these first two terms. If you have two terms of a GP, a, comma c, three terms are upon a. Okay. So using this logic, I have written down the fourth. So you have everything in terms of two variables, a and d this only. This minus this equation a, the whole square upon a plus d minus a is equal to 30, because this is an increasing sequence, correct? So it's going up like this, increasing for positive integers. Keep all of this in mind. Solve this equation mainly. Acha, one more thing. This class has been going on for few classes now. I usually share the link for this document in the group during the middle or towards the end of the class. So you can go through all the previous questions that were discussed also. Okay, take it from the chat. If you miss it this time, 2 weeks later again, I'll send the same link. I think only few of you are thinking about this question hard. This is quite complicated to figure out what A and D could be given these conditions. I would suggest you remaining part as a hook. Let's do a much simpler question. Homework means next class, 2 weeks later, we will discuss it. So Ishan, there is no group that exists. It's just that you get this link through your mail every time, and we meet bi-weekly. Okay. Try question 24. It's much simpler. Ishan is also asking which chapter is going on. This is geometric progression currently. Positive integers a, b, and 2009 with always increasing form a geometric sequence, and with an integer a is also an integer, b is equal to ar, and 2009 is ar. A is an integer, b is an integer, ratio is also an integer. You have to find what exactly is a. Aryan, not correct. Try again.
Sir, mine is correct.
Adya, correct. Aryan, you have done everything correct, I think, but you missed some calculation error you might have done. Roshan, correct. Shivam, correct. Pranshu, you have found the term before a, not exactly what a is. Chirag, not correct. Abhyuday, correct. Chirag, you have found r square instead of a. Pranshu, Abhyuday, correct. So here you have to do nothing apart from factorizing 2009. So a good trick for factorizing large number is that make a checklist 2, 3, 5, 7. Possible case the number that either divides or one or more of these. Webber, not correct. So 2, 3, 5 obviously are not dividing 2009. 7, 11, and 13. A fast trick to check for divisibility by 7, 11, 13 is, okay, you take your number 20009, split it into two parts. Like take the rightmost three digits, make it one group. Next three digits, make it another group. Bring this two below. Basically, if you have even more number of numbers, what you add them up. So what you'll do is you'll do 9 minus 2. Whatever number that comes out in the end, it will be a 3-digit number or a 4-digit number, whatever. That is much, you can repeat the process again. In the end, you'll get a 3-digit number or lesser number. If this number is divisible by either 7, all of 7, 11, and 13. That is because 1001 is times 11 times 30. So it's very, you can quickly divide a very large number and check for divisibility by 7, 11, 13 in one shot. So you can also divide by 7 and check, or use the other divisibility test for 7, which is take the last digit, what do? Take 9 and subtract by 18, and then whatever number you get, you take multiply and keep going. You'll find it 2009 divided by n, you get further division by 7, because 287 is also divisible by 7 again, you get 41. So from here you can say that 2009 is equal to ar square is equal to 41 times 7 square. Now one possibility is that r is equal to 1 or 7. Nothing else will work. R equal to 1 will give K all the terms A, B, and C are not strictly in a ascending order. So you will have to say that R is equal to 7, A is equal to 40. Okay. Try to go through this. If anyone has any doubt, you can ask me. Try this next question.
So can you explain this question again?
I'll do that second. Question 25. You can either note this down or you can like put it in. Take a screenshot of it. Huh. What part did you not understand? Or completely blank? If completely blank, I'll start from the beginning.
Yes, so we'll start from the beginning.
Okay, so you have three positive integers A, B, and 2009. I have written them in a GP. They form a geometric sequence. So A is A, B is AR, and 2009 is AR square. Okay. Another condition given to us is that A is less than B is less than 2009. So I can't somehow write that down over here. I'll just keep it in the back of my mind. Then I will also see that with an integer ratio. Correct. And ratio is R over here. And if R is an integer, I have 2009 factored into AR square. Now I will factorize 2009. It turns out that it is 41 times 7 square. Since 2009 can be written as a product of a perfect square and another integer in two ways only. It's either 2009 times 1 square or 41 times 7 square. If R was equal to 1, then A would equal B would equal 2009. But that would violate this condition. Okay, we need a strictly ascending sequence. So R equal to 1 is removed and you are left with R equal to 7 and you get A equal to 40. Got it?
Yes, sir.
Try question 25. Zaid not correct. Aryan correct. Very good. Roshan not correct. Try again. So it is given in question 25 that the sum is a positive number. Okay. So see, if it was not given that the sum is positive, then answer would be minus infinity because you can take first term as infinitely small. I'll give you one situation. If A is equal to minus 1000 and second term AR is equal to 1, then AR square will again be a very, very tiny quantity 0.00 minus 0.001 and so on. We'll keep going. But S will be approximately minus 1000 only. That is, I am showing if A was very, very small, like in negative, its absolute value very large, but it's negative, then the sum of that infinite geometric progression, S, will be very, very small. But it is given that it's a positive number, so you can't have, you cannot consider these cases where S becomes negative. It will have a smallest positive value. Again, I'm saying positive value. So whoever is saying 0, you are wrong. If you are saying -1, you are wrong. Pranshu not correct. Om not correct. Alok, answer is incorrect. Answer is a real number. Okay. Shubh correct. Rudra not correct. Vaibhav correct. Think a little. Write some equations. Figure out the common ratio first of all. Then try try to write an equation and try to get the smallest value possible for that equation. Pushkar, not correct. Rudra, not correct. So Rudra is saying 1 upon infinity, which is like trying to say okay, answer should be 0, but I'm considering it positive, but that also doesn't work. Answer is not 1, okay? Answer is not 1, answer is not 2, answer is not -1 also. So, in case you're like Ishan is having a lot of trouble with this class. See, the thing is, these are problem solving seminar. I am not treating it as a classroom where I give a theory and I will teach theory and I will go over the concepts. I'm just giving some interesting questions that you can think about during the class and later on also. This seminar is limited in scope in the fact that I'll be having only two classes, not at all sufficient to cover any syllabus for any exam. It's just for fun. Okay, you try to test out your knowledge in a particular topic every 2 weeks.
So can you explain question number 22?
Explain question 52.
Yes.
This here you have this is a PQ square, P cube, and so on. Equal with Q cube and so on to infinity equal to 3. So these are both sum of GPs with first term P common ratio Q and first term ratio P. Using this information, I can write sum of those GPs in terms of its reduced form, like A upon 1 minus R. This so I get two linear. Shivam, correct answer. Abhyuday, correct answer. Roshan, not correct. So in the end, you 48. Okay, I'll solve this question right now. So with the first term A, next term is 1. Now from this you get that the common ratio R must be equal to 1 upon A. So the next few terms that you can write is 1 upon A, 1 upon A, and this is first term. Second term is supposed to be AR. But AR, if it is equal to 1, then common ratio is 1 upon A. Adya, no, Adya, not correct. Try again. So from S R, which is equal to A upon 1 minus 1 by A, or in other words, you get A square upon 1 A minus 1. This is equal to, okay, so I'll remove infinity from here and just simply write S. S is a positive quantity and you need to find whatever minimum positive value of this quantity can have. Ohm, Adya, not correct. Alok, correct. I'll give 2 more minutes, 1 more minute to figure out, for you guys to figure out the smallest value of this. Adya, correct. Very good. So those who are saying कि it's approx 0, the thing is it can't have a positive value above 0. Value of this is possible to be 0. If you put A equal to, let's say 0, You put a equal to 0, you get your numerator as 0 and denominator as some negative number. But why should that matter? Answer is 0. But it is also given that s is not a negative number. It's a pure positive number only. So a equal to 0 is although not valid. If you put anything just above 0, numerator will be positive, denominator will be negative. That would make your entire result slightly negative. It will never be slightly positive. So answer 0 cannot be possible. Correct. So to solve this, first of all, why have a perfect square in the numerator? Divide it and get some remainder of this quantity in the numerator. What you can do over there is a square. You can write a minus 1 the whole square plus 2a minus 1 upon a minus 1. And here you get a minus 1 plus 2a minus 1 upon a minus 1, which is equal to a minus 1 plus 2 plus 1 upon a minus 1. Okay, so 2a minus 1 also you can write as minus 2 plus 1. Okay, and then you can common and get. I've just taken this a square divided by a plus a minus 1, written whatever the quotient comes out to be, and the remainder. Remainder I'll leave as it is on that fraction. Now what you'll see very interesting is that I've already split it into the form that I want it in. A minus 1 plus 1 upon a minus 1 plus 2. This is the sum of two inverse quantities. It's like writing x plus 1 upon x plus 2. And if you know the positive value of this quantity is 2, because I will invoke something called AM-GM inequality. AM greater than equal. What is AM? This is if you have a plus b by 2 and GM will be under root AB. This is called the arithmetic mean. This is the geometric mean. If some of you are like going on over here, and first seeing this vertical inequality, it's used very commonly to solve this kind of an expression. The arithmetic mean, so x plus 1 upon x upon 2 will always be greater than or equal to under root of x times 1 upon x. This will cancel and you'll get 1. So from here you'll have 1 upon x to when x greater than equal to 0. Also you'll have x plus 1 upon x less than equal to minus 2 when x. The graph of x something like this. Okay, this is x plus 1 upon x. Once you get, now why did I not consider the negative values over here? I can consider the negative values also. But the thing about the negative values is that it will make it either 0 or less than 0. The value of s will either be 0 or less than 0 because there is a plus 2 over here. Now, this point is minus 2. Minus 2 negative or non-positive. So this is how I solved it. In case you know differentiate this, of course you will reject, and this will be your answer. Okay, those in lower classes if in case you are confused, I am doing content at the level of EMC 1012. So it is quite possible that you get confused. We can try this last question.
So could you scroll up?
Question 26. Sum of first 2010 terms of 2011 terms of a geometric sequence is 200. Sum of first 4200 is 380. Then what will be the this will inevitably become a homework question only, but I'll give you 2 more minutes. After that, I'll write the short reasoning for this. Chirag, answer is not correct. Shubh, not correct. Shubh, you are very close. Rishit, no, it's not that large. Harshit, very close, but not correct. You're off by 2. Check where you might have gone wrong. This is a geometric sequence that I'm talking, okay, not arithmetic. Harshit, your answer is correct for an arithmetic sequence. Actually, it's not correct for arithmetic also. It is correct for arithmetic, sorry. So the complicated way of looking at this question would be that 200 is equal to first 2000 terms. This is A times correct. The next equation you'll have is 380 is equal to A times R to the power 2 4022 minus 1 upon R minus 1. Then you have question mark is equal to A times R to the power 6033 minus 1 upon. This is a very complicated way of looking at this question. I'll give you the answer next week. Next to next week, we'll discuss the easier reasoning behind this question. Should I give the answer or should I not? I'll do one thing. I'll update the answer in the document. Uh, I'll share the link again. Okay. I'm sharing the link again in the chat. Zaid, correct answer. Shubh, correct. Okay, so after the meeting ends, I'll put the answer in the document over here and you can refer it. In case you don't want to see the answer and still attempt it, you can take a screenshot of this right now. And then next week, I'll show you the very, very quick and easy method to solve it. Answer is 1 less than whatever you have written. 1 less than whatever you have written. Okay. I'll end the meeting then. Good. We'll weeks later, okay?